If you've ever opened a fresh soda and heard that sharp psst, you already know fizz is part of the experience. Those bubbles make soda feel cold, crisp, and alive. But leave that same drink sitting out for a while, and suddenly it tastes flat and lifeless. So where did all that fizz go? Today we're breaking down the science behind carbonation and answering the question, why does soda lose its fizz? Right here on History of Simple Things. What fizz actually is. Fizz is made of carbon dioxide gas, or CO2, dissolved into the liquid under high pressure. Inside a sealed soda can or bottle, carbon dioxide is forced into the drink until the liquid becomes saturated with gas. As long as the container stays sealed, the pressure keeps the gas dissolved. The moment you open it, pressure drops, and the carbon dioxide wants to escape. That escape is what creates bubbles. Fizz isn't just gas. It's gas that's been temporarily trapped in liquid. When you crack open a soda, you're instantly lowering the pressure inside the container. This makes the dissolved CO2 unstable. Gas always tends to move from an area of high pressure to an area of low pressure. As a result, the carbon dioxide begins to leave the liquid and form bubbles that rise to the surface. That's why soda starts bubbling immediately after opening. It's not suddenly creating gas, it's releasing gas that was already there. Bubbles don't just appear randomly, they need tiny imperfections called nucleation sites to form. These can be microscopic scratches in the glass, dust particles, or tiny fibers. CO2 collects at these spots, forming small bubbles that grow and rise. This is why soda fizzes more in a rough glass than a perfectly smooth one. More nucleation sites mean more places for bubbles to start. Shaking a soda creates thousands of tiny bubbles inside the liquid. These bubbles cling to each other and to the container walls. When you open a shaken soda, all that trapped gas suddenly expands at once. The pressure drop causes rapid bubble growth, pushing liquid out in a fizzy eruption. It's not that shaking adds gas, it just helps release it faster and more violently. Cold soda holds more dissolved CO2 than warm soda. That's because gases are more soluble in colder liquids. As soda warms up, it becomes less capable of holding on to carbon dioxide. The gas escapes more easily, making warm soda go flat faster. This is why warm soda tastes flatter, and why cold soda keeps its fizz longer. Pouring soda into a glass increases surface area and introduces more nucleation sites. As the liquid splashes and spreads, CO2 escapes more rapidly. That's why soda in a glass often loses fizz faster than soda left in a sealed bottle. The act of pouring itself accelerates degassing. Why diet soda loses fizz faster? Diet sodas often seem to go flat more quickly. One reason is that artificial sweeteners change how bubbles form and behave. Sugar increases the thickness, or viscosity, of soda slightly. This can slow bubble movement and help retain carbonation longer. Without sugar, bubbles can rise and escape more easily, making diet sodas feel flatter faster. Some of the CO2 in soda reacts with water to form carbonic acid. This weak acid gives soda part of its tangy bite. When CO2 escapes, carbonic acid breaks down. That reduces both fizz and some of the sharp flavor. So, flat soda doesn't just lose bubbles, it loses part of its taste chemistry too. Putting the cap back on slows fizz loss, but it can't fully restore pressure. Once CO2 escapes into the air, it's gone. Resealing only traps whatever gas remains. That's why reopened soda never tastes quite as fizzy as when it was first opened. That satisfying hiss when you open a soda is the sound of pressurized gas escaping. It's the audible proof that carbon dioxide is leaving its dissolved state and becoming a gas again. Your ears are literally hearing physics in action. Ice cubes add more nucleation sites and cool the drink unevenly. As ice melts, it introduces movement and surface irregularities, giving bubbles more places to form and escape. This is why soda over ice often loses fizz faster than soda straight from the bottle. Different sodas are carbonated to different levels. Some have more dissolved CO2 than others. Colas, sparkling waters, and energy drinks all use different carbonation pressures and formulas. More dissolved gas means more bubbles and a stronger fizz sensation. Fizz isn't just texture, it affects how flavor hits your tongue. Carbonation stimulates nerve endings, making flavors feel sharper and more refreshing. When the fizz is gone, the sweetness and syrupy notes become more noticeable. That's why flat soda often tastes overly sweet and dull. How long does fizz really last? Once open, soda starts losing CO2 immediately. Within minutes, noticeable fizz is gone. Within a few hours, much of the carbonation has escaped. By the next day, most sodas are largely flat. It's a slow leak you can't see, but it's always happening. Soda loses its fizz because carbon dioxide is escaping back into the air. Pressure drops, temperature changes, and tiny imperfections all help gas find its way out. What feels like a simple flat drink is really a lesson in physics, chemistry, and gas behavior. So the next time your soda goes flat, remember, it's not broken. It's just obeying the laws of nature. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.